In this video, we're going to do a basic introduction to autonomous, so that first 15 seconds of a match. And what we're going to do is just talk about the structure of autonomous commands, and then write a basic autonomous sequence and add it into code. So our adventure into autonomous begins with these two methods right here, autonomous init and autonomous periodic, inside robot.java, where we first started writing our code. And you'll notice that not a lot happens in autonomous periodic in terms of, running code. Uh, see, it's literally empty. But we actually focus more on autonomous init. And what really is going on is there's a call being made to robot container to get an autonomous command, which I'll show you in a second. And then the autonomous command is scheduled, meaning it's going to be ready to run once autonomous is enabled. So in robot container, is actually where we return the autonomous sequence that we want to run. So what we're going to talk about today is how we actually make this command in the first place. So creating autonomous commands are actually a little bit different than creating normal, subsystem commands. Because the thing with autonomous commands is that you're now running multiple commands, sometimes sequentially, sometimes at the same time, and sequential and parallel command groups are, the key command groups that we're going to be working with today. So essentially what we're going to be doing is learning how to integrate the commands that we wrote for our subsystems into these command groups that we'll be working on. So inside commands, let's create a new sequential command group. So you'll notice that for command group, you have parallel and sequential. So a sequential command group, well, it's just a group of commands. So imagine like a list in your head, and that list runs from the top to bottom. And the command will literally end when the last command in the sequence is over. So unlike our normal commands in the past where you can specify the end condition of sequential and parallel command groups are determined when in a specific command ends. So it's not that you can't specify end conditions inside the groups, but you can specify the end conditions inside the individual commands that run within the group. So all you really need to like think about in terms of sequential and parallel command groups, and obviously parallel is all of them running at the same time. And the key thing about parallel, however, one thing to make sure that I almost forgot, is that a parallel command group will end when the final command ends, if that makes sense. So all the commands are going to run at once, but some will end earlier than others. So the command group will end when the last command is run. So we're going to focus on some basic routines, and as you'll progress in your autonomous journey, one thing you'll realize is that you're actually going to have to end up making sequential and parallel command groups within each other. So you're going to have sort of a nested structure. It's totally normal. So the reason why we want our main command to be a sequential command group is because at the root of everything, you want everything to run sequentially. You don't want everything to run at once because that doesn't really make much intuitive sense. Because unless you have a very, very basic routine, usually things happen in a sequence, something like, oh, go pick up a game piece, then drive back to score the game piece, etc. So at the root of our entire command, it's going to be a sequential command group. And let's call this auto command because that sounds cool, I guess. Okay, so you'll notice immediately right here that things look a little bit different. So the way that autonomous command groups work is that, remember, we only really need to run each command in sequence, and that instance of this command group, so this specific auto command group, is only really running once, right? There's nothing that needs to happen periodically in the context of the macro command group. Now, obviously, there will be periodic things happening within the specific commands and subsystems that we call, but not in the context of the overarching command group. So the way it works um, is rather than worrying about taking in stuff and declaring stuff, etc., everything happens inside the constructor. So what we're going to talk about right now is making a very basic auto command that drives forward for a second. So in order to do this, we're going to take in the drive subsystem, we'll call it drive, and then the main place where you run your commands is this add commands right here. So inside add commands, we are going to we're going to run rather the command that lets us drive, right? Because this is a command group. So command group is going to take a group of commands. So you're not going to call drive this the methods within drive subsystem, but you're going to call the commands that are associated with the drive subsystem. So in this case, let's run a new arcade drive command. So you'll notice we have our two double suppliers, right? The first one is translational, the second one is rotational. So rotational, and again, these are suppliers. But the key part about autonomous is that you decide the parameters. You decide how fast you want the robot to run, right? Not the driver, it's you. So all you really need to do is pass in however fast you want this drivetrain to run. So I'm going to run it at 0.25 just for safe measures. And then I don't want it to rotate. I just want it to move straight. And that's it. This parentheses should not be needed. Uh-oh, do not like that. Yeah, that's one thing about these command groups. They get a little iffy. I think that's the one. Yep, okay. So the key thing about command groups also is you want to make sure your parentheses are correct because the way that add commands works is each command is separated by an instance of a comma. So there's no semicolons involved inside this add commands method. You separate each command with a comma, and the last command does not have a comma after it. So that's something to keep in mind in terms of syntax. So we've written our very basic drive command. And again, we pretty much already wrote this, right? Because all we're really doing here is just calling the arcade drive command, except the only difference is rather than taking joystick values, we're just taking in a percent output that we specify. So in order to run this, you'll go ahead to robot container. Instead of returning null, you'll return new auto command. And it's in taking the instance of the drive subsystem that we initialized inside robot container. So return new auto command. Now you can deploy this, and if you enable your robot in autonomous, you'll see that the drivetrain runs. But something to keep in mind is that it actually won't stop. And this goes back to the idea that, remember, these command groups are going to end based on the end conditions specified by arcade drive command. Now, what are the end conditions of arcade drive command, you ask? Well, let's look back. You'll notice that, oh, wait, there's nothing. Like, is finished returns false, which means that, well, this is going to run forever. So that's where WPILib has something called with timeout. And you can actually specify how long you want each command to run. Now, timeout is super useful for commands like arcade command that don't have a specified uh, end condition, and you want to just run a command for a certain amount of time. You can add dot with timeout to the end of it, and it'll run for a specific set of time. So now you can go ahead and deploy this, and it'll run for 1 second. Okay, so now let's sort of evolve this command a little bit. Now let's say I want to be able to intake while driving. Now you'll notice in terms of like the way I worded that intake while driving, that hints at, oh, parallel command. We need things to run at multiple times, or rather not multiple times. We need things to run at the same time. So what we're going to do now is take an instance of the intake subsystem so that we can actually call the run intake command. And what we're going to do now, because this is a sequential command group, we're going to have to do is make a new parallel command group within the sequential command group. So again, this is where we're talking about that nested structure. And the way you do it is, or I guess the way it's declared, I'm just going to quickly copy this so you can see it. The way it's declared is new parallel command group, and you can kind of treat this like a method in a way. It's not really a method, but like it's sort of just the argument. It's sort of just like instantiating something new, you know? So you pass in the arguments, and again, it's the same exact syntax separated by commas. So we have new arcade drive command with timeout 1 second. We also have new run intake command. And again, we're going to run this for 1 second. So I'm going to add dot with timeout 1. Now, something you might notice is, and again, don't forget the comma to separate the command. Now, something you might notice is, well, these both need to run for 1 second. So can I just run this entire command group for 1 second? And the answer is, well, yes, you can. So you can get rid of these timeouts, actually. And all you need to do is, well, we're only concerned with running this command for 1 second, right? Or this command group, rather, for 1 second. So you can actually add a timeout to the entire command group for 1 second. Now, let's say I want to drive back. Well, we have this command group here. And remember, the overall add commands part of this is a sequential command group. So I don't need to make a new sequential command group. I can just do comma, new arcade drive command, and let's say I wanted to drive backwards, so I'll pass in a negative 0.25%. And this can just be 0. And now I'm driving back after I've run this parallel command group. So you can obviously get a lot more complicated with this. I encourage you to try to, do things like, oh, run the shooter, do other things in parallel, etc. Because the possibilities of doing things in parallel and sequential is pretty much limitless. I mean, you could do things entirely sequentially. You could do things in parallel. I mean, it's up to you to figure out what's the most time efficient and what's the most accurate for your robot. And one thing we just need to fix at robot containers, this will take in the intake subsystem now. And yeah, so you can go ahead and test that out too. So that's basic autonomous. Obviously, this is going to evolve as we get into more complicated subsystems and as you learn more and grow. But one thing to keep in mind is that the structure of your commands is still always going to be sequential command group, parallel command group. It's going to follow that structure. So that about wraps it for this video. We'll catch you in the next one.